Hello and welcome back everyone. Into this video where we are going to talk about actuators and special kinds of actuators. Now this fourth chapter is quite a special chapter because this will not only tell you how you can explore different kind of material and actuators, but this will also tell you some of the actuators which are very commonly available as well. So you can literally like go to Amazon and buy them. It's that straightforward. And I feel that this chapter plays a very important role when it comes to understanding of actuators and what is the limit of an actuator really is. Okay. Now, without any further ado, let's actually jump into the chapter. Also, one more thing, some of the topics which are going to be here in this chapter are actually directly implementable, which means if you go to Amazon, you can actually buy these actuators as well. And you can try them on, on different use cases, different, materials and different robots, of course. And I would highly recommend that, to be honest. If you really want to get into robotics, having a hardware is the best thing you can do. Having the right component and trying out the best component would be amazing. And especially if you can afford it, I would highly recommend, affording them and buy them. But it's not a compulsory thing, of course, but if you can spend, save some money from here and there and, save thousand rupees as well, let's say, you can buy a good robot. Let's say you take the example of this one. And this one costed me like, I think 3,000 or something. But this is a really good investment because this is a very simple yet powerful robot which you can try a lot of things on. So a lot of robots that you see are not that expensive. Okay. So that's my main motivation that the reason why I'm telling you is that, if you buy something like this, you can actually try it. You can, give it a shot. You can feel how a robot feels. And, of course, you can program it and you can do a lot of things. So that's going to be my motivation and, inspiration to you that, maybe save some money, try it out, buy it out as well. Without any further ado, let's actually get into the chapter. So, okay. So we're in chapter 4 of module 2 now, and we are going to move ahead with this. So let's see the definition of advanced actuators. Okay, advanced actuators, specialized actuators that provide a unique capability of robotic system. Now, when we talk about unique capabilities, it means features that are not readily available and that requires something which is a little unique. Okay, but which is very specific as well. Okay, specification or specific needs solving of a actuator is very important. That what you are working on and what exactly it has to be worked on. That's something that need-based solving is something which is going to be very, very important. Okay, advanced actuators are designed to perform tasks that are difficult or impossible to accomplish with standard actuators. When I say difficult or impossible, it means that you would require either a lot of adjustments or you would require extreme amount of changes and modification, which at some point it doesn't really make sense. So these actuators solve that problem and give you the results that you want. And there are several types of, advanced actuators used in robotics. Let's start with the first one, which we have already done before, which is shape memory alloy. In the last chapter as well, we were talking about shape memory alloy, SMA, which can change shape when subjected to heat or electrical current. Okay, which are essentially used in soft robots or for medical engineering. Okay, when you want to explore some sort of different materials, or when you want to make a robot that can go inside the human body and still be able to retain its shape, SMA or shape memory alloy are quite popular. You can buy the fact, you can actually go to Amazon and also search for a shape memory alloy and you will actually find a shape memory alloy wire or SMA wire. Okay. You can actually buy it. You can, whenever you put like heat, or you can put heat on it and you can change the shape. And whenever you apply electricity, you can actually get the shape back. Very cool wire. I actually had one of those wires back in my, bachelor's days. But yeah, but very, very fun memory to play with. Then you have SMA actuators, which are shape memory actuators, which are the same thing, or the wires, which are lightweight, provide a high force to weight ratio, making them ideal for application where weight is a concern. Okay, whenever we talk about soft robots, okay, anything which is going inside your body or biological robots, okay, shape memory alloys play a very important role because they can change shape and they're very lightweight as well. Weight is always a concern when when you're putting things inside human body, and I think this plays a very important concerning role that shape memory alloys can play decent amount of roles and making this happen. Then you have electroactive polymer or EAP, okay, actuators which are material that change shape when electrical current is applied. Okay, usually when you apply current, then they start to change shape. Okay, they are also kind of shape memory alloy, but they are polymers. Okay, so they are polymers, which means that they don't really have a materialistic or means like metal finish to themselves. They're more of like synthetic materials like plastic and carbon fiber. And EAP are generally start to change shape when, only when current is applied, not when heating is applied. Okay. EAP actuators are lightweight and can provide large displacement, making them ideal for applications that require high degree of flexibility. Okay, let's say you have a joint. Okay, let's say you have like a folding joint, or you might have seen the Samsung smartphones which are like folding these days. They also actually have EAPs inside. Okay, that's what make these joints so flexible yet super conductive as well. So the actuators which are there, okay, are basically going to be helpful when you want to make a major displacement, when you want to apply electricity. And that's where these EAP comes in picture. Then you have the most popular one, which is piezoelectric actuators. Now, this is extremely popular, very cheap and affordable as well. You can buy on Amazon, I think, for 100 bucks, 100 rupees INR, and very affordable. Piezoelectric material generate electricity when subject to mechanical stress. Whenever you apply force or stress, then these start to produce electricity. Quite an important application if you see that you are building something where you need to convert a force on the streets or force on the roads into something else, or force on some sort of mechanical places into something else, or just you want to create a electrical signals. That's where these come into picture, and they play a quite an important role over there as well. Piezoelectric actuators can provide precise high frequency motion and are commonly used in micro robotics and precision manufacturing. Whenever you see like small, what do you call, chips or small controllers that are manufactured, all of them actually have piezoelectric actuators that moves 1 micrometer. Okay, 1 micrometer. That's all. So micrometer, micromillimeter. You can get high level of precision with these actuators, and they can give you extremely accurate results when they are in action. So that's why these are like really powerful actuators. Then you have shape memory polymers. Okay, if you remember, we talked about shape memory alloys and the polymer EAP. Okay, when you combine both of them, you get SMP, shape memory polymer, are material that change shape in response to change in temperature. Okay, over there, EAP were only changing shape when we were applying electricity. Over here, SMP change shape when you apply temperature. Okay, so if your application or use case is a temperature sensitive application, then SMP are a better choice for your use case. They can also be used for self-folding structures. If you have seen, folding structure which can fold themselves, or, any sort of space exploration materials, then you use SMP. Quite an important aspect. Okay. Advanced actuators are important in robotics because they provide unique capabilities that are difficult or impossible to achieve with standard actuators. When you can't really achieve some capabilities with standard actuators, that's when, you use smart advanced actuators. Advanced actuators enable robotic system perform tasks like efficient, precise, and flexible manner. Okay, whenever you need extreme efficiencies, that's when you touch on use all these actuators. They're not really that commonly used because, first of all, they're very expensive, and planning and using them can require you to make special arrangements, and that should make them a little more difficult to use as well. So then in that case, you need to make sure that okay, this actuator or this system is actually capable only when you need a very specific use case. So that makes them quite unique thing. Okay. Some example of advanced actuators used in robotics can be as follows. Okay, SMAs or shape memory alloys used for controlling the motion of robot fingers in surgical robots. Okay, because since you have to move the surgical fingers very small, in a very small distance, okay, it can be very difficult if you use a motor. Okay, that's when you use SMA or shape memory alloy to pull the string very slowly and very precisely. Okay, very, very important, by the way. EAP actuators are controlled in robot fish underwater environments. Okay, because since EAP are actually capable enough to only move when electricity is applied. Okay, if you want to move the fin or if you want to move the tail, then EAPs are quite a good material for that. Piezoelectric are used in for micro robotics for precise manufacturing. As I mentioned, when you're talking about manufacturing a small controller, okay, when you're talking about manufacturing a small chip or a system on chip SoC, that's when piezoelectric materials or piezoelectric actuators come into play, and they play a quite important role over there. SMP, however, they're used for creating self-folding structure in space exploration. If you want to fold, if you want to create a structure which is going to fold itself, then you use SMP. Quite important topic as well. In conclusion, okay, advanced actuators are specialized actuators that provide unique capabilities to robotic systems, which are easy, can be used, and can have a lot more capabilities. There are several types of advanced actuators used in robotics, including SMA, shape memory alloy actuators, EEP actuators, piezoelectric actuators, and SMP actuators. Okay, all of these are quite important, and all of these play a very important role, of course. Understanding the different types of advanced actuators and their application is essential for designing and building effective robotic system. Of course, you want to be effective in making your robots. If it's not effective, it's not gonna be helpful. And that's it for this chapter. I hope you understood. Okay, let me come back to my main camera. Yeah, I hope you understood what we were trying to say, and what I was trying to say. When we select particular actuator, not every time you would use these kind of actuators, but these are very obviously very helpful and very powerful in a lot of use cases, and that's what the main idea is. And you should know when do you need to choose them and when you not need to choose them. But that's it for this lecture, for this class, actually, for this chapter. I'll see you all in the next one. Till then, happy learning and peace.